Have you ever wondered how the tiniest particles in the universe behave? This question sparks our journey into the mesmerizing realm of quantum mechanics, a field of physics that delves into the behavior of matter and energy at the most minute levels. Quantum mechanics is not your everyday physics, it's the physics of the incredibly small. We're talking molecular, atomic, nuclear, and even smaller microscopic levels. This is a place where the rules of classical physics, the ones you learned in high school, no longer apply. Here, particles can exist in two places at once, pop in and out of existence, and even affect each other regardless of distance. Sounds a bit like science fiction, doesn't it? But it's very real, and it's called quantum mechanics. But where did this all begin? Let's turn back the clock to the early 20th century. The year is 1900. A brilliant physicist by the name of Max Planck makes a revolutionary proposition. He suggests that energy, instead of flowing in a continuous stream, comes in discrete packets called quanta. This idea was so radical, so out of the box, that it marked the birth of quantum mechanics. Then, in 1905, another luminary enters the stage, Albert Einstein. With his theory of relativity, Einstein shook the foundations of physics, introducing concepts like space-time and the equivalence of mass and energy. His work had profound implications for quantum mechanics, setting the stage for future leaps in our understanding of the quantum world. So here we are, over a century later, still fascinated by the world of quanta. Quantum mechanics has not only reshaped our understanding of the universe, but it's also an integral part of technologies we use every day, from smartphones to MRI machines. So, ready to dive deeper into this fascinating world of quantum mechanics? Stay tuned as we venture further into the quantum realm, where the only thing you can expect is the unexpected. What if I told you that a particle can be in two places at once? Yes, you heard me right. In the quantum world, particles can exist in multiple states at once. This is due to a concept known as superposition. It's as if you were both sitting and standing simultaneously until someone observes you, and only then would you be either sitting or standing. Sounds wild, doesn't it? Well, hold on to your hats because it gets even wilder. Imagine a particle, let's say an electron. Now, this electron isn't just an electron, it's also a wave. And this isn't some kind of strange transformation. No, it's both a particle and a wave at the same time. This is known as wave-particle duality. You see, the quantum world doesn't play by our everyday rules. In the quantum realm, particles are more like blurry, buzzing bees, rather than well-mannered, predictable billiard balls. And it's not just about being blurry. They have this uncanny ability to be in multiple places and in multiple states all at the same time. But how can this be? Well, that's a good question. And the answer is, we don't exactly know. These quantum phenomena defy our everyday logic and intuition. But don't worry, you're not alone in this. Even the greatest minds in physics have been perplexed by the quantum world. And when we say things like particles can exist in multiple states at once, we don't mean that they are literally in two places at the same time. It's more like they exist in a state of uncertainty, a state of potentiality, until they are observed or measured. And it's at that moment, in that act of measurement, that they choose their state. Isn't it mind-boggling to think about? But that's the quantum world for you. It's a world that's both unpredictable and fascinating. A world that pushes the boundaries of what we thought was possible and challenges us to see reality in a whole new light. What happens when two particles fall in love? This isn't a cheesy pickup line, but the heart of a concept that is as intriguing as it is mind-boggling: quantum entanglement. It's the idea that two particles can become so intimately connected, so entangled, that the state of one instantly influences the state of the other, regardless of how far apart they are. Imagine for a moment that you and a loved one each have a pair of dice. You're in New York, and your loved one is in Paris. You both roll your dice at the same time, and every single time, without fail, you both roll the same number. It's as if the dice are communicating with each other in real time across thousands of miles to ensure they always match. This is the essence of quantum entanglement. But here's where it gets even stranger. These entangled particles aren't just mirroring each other, they're doing it instantly. The moment one particle changes, the other does too, no matter the distance. This is a concept that doesn't just challenge our everyday intuition, it also challenged one of the greatest minds in history, Albert Einstein. Einstein's theory of relativity tells us that nothing can travel faster than light. Yet, in the quantum world, it seems that information between entangled particles does. This apparent conflict between quantum mechanics and relativity led Einstein to famously refer to entanglement as spooky action at a distance. Yet, despite Einstein's reservations, quantum entanglement has withstood rigorous scientific testing. It's real, and it's one of the most fascinating aspects of quantum mechanics, offering potential for breakthroughs in areas from computing to communication. So, what happens when two particles fall in love? They become entangled, creating a connection that transcends space and time, challenging our understanding of the universe and the nature of reality itself. Quantum entanglement, it seems, is a love story that defies the laws of classical physics. Ever wondered how your smartphone works? It's not just a marvel of engineering, but also a testament to the wonders of quantum mechanics. Yes, you heard it right, quantum mechanics, the science that delves into the behavior of particles at the smallest scales, is at the heart of the technology we use daily. Take transistors, for instance. They're the building blocks of all digital devices, from your smartphone to your laptop. These tiny switches control the flow of electricity, turning it on and off to represent the ones and zeros of binary code. But how do they work? It's all thanks to quantum mechanics. At the quantum level, particles can tunnel through barriers. This quantum tunneling is what makes transistors possible, allowing electrons to move through an insulating barrier when they shouldn't be able to according to classical physics. Next, consider semiconductors, the materials that make up transistors. Semiconductors rely on quantum mechanics too. They can conduct electricity under some conditions but not others, thanks to the quantum properties of electrons in their atoms. And it's not just our digital devices. Lasers, those powerful beams of light, owe their existence to quantum mechanics. The word laser is actually an acronym for light amplification by stimulated emission of radiation, which is a process that can only be explained by quantum theory. Lasers have countless applications, from barcode scanners and printers to fiber optic communication and medical surgeries. Even medical technology like magnetic resonance imaging, or MRI scans, wouldn't be possible without quantum mechanics. These scans produce detailed images of the inside of our bodies by aligning the spin of hydrogen atoms in our tissues, a process that's fundamentally quantum. So you see, quantum mechanics isn't just about esoteric theories or far-off galaxies. It's right here, in the devices we use to communicate, the machines that keep us healthy, and the technology that powers our modern world. Quantum mechanics, as abstract as it may seem, is deeply intertwined with our everyday lives. Can you imagine a future powered by quantum technology? In a world where technology is rapidly evolving, quantum mechanics could be the next big leap forward. We're on the brink of a new era, where the strange and fascinating laws of the quantum world could revolutionize our everyday lives. One of the most promising applications is quantum computing. Traditional computers use bits, which can be either a 0 or a 1. Quantum computers, on the other hand, use qubits, which can be both 0 and 1 at the same time. This allows quantum computers to process information at an incredibly fast rate, solving complex problems that would take traditional computers centuries to crack. Next, we have quantum cryptography, a secure communication method that uses the principles of quantum mechanics to encrypt data. The beauty of this technology is that it alerts the sender and receiver if a third party tries to eavesdrop, making it virtually impossible to hack. Quantum teleportation, while sounding like a sci-fi concept, is another potential application. It's not about teleporting physical objects, but rather the information about the quantum state of a particle. This could revolutionize the way we transmit data, making it faster and more secure. Yet as we venture into this quantum future, we face significant challenges. The technological limitations are daunting, as creating and maintaining a stable quantum state is no easy task. The quantum world is delicate, and even minor disturbances can cause a quantum system to collapse. Moreover, there are ethical considerations. The power of quantum computing could potentially be misused, leading to unprecedented security threats. It's essential for us to establish robust ethical guidelines and regulations to prevent such scenarios. Despite these challenges, the potential of quantum mechanics is too great to ignore. As we continue to unravel the mysteries of the quantum world, we're paving the way for groundbreaking innovations that could transform our society. Quantum mechanics, as perplexing as it is, holds the promise for a future we can only begin to imagine.